So the question I'm doing is 2011 final exam question 2, which is the text question, which is an incomplete information game. So there are two players, and each player has two types. The high income type denoted as a small letter h, and the low income type denoted as a small letter l. So both of them have two actions. One is reporting himself as the high type, and the other one is reporting himself as the low type. To distinguish notation, I'll use capital letter H and L to denote actions. So H and L are basically reports. And the table I have here is basically for each one of the player, I actually have two different opponents. One is the high type of the other guy, the other is the low type of the other guy. And they happen with different probabilities. So the other guy being the low type has probability P, and the other guy being high type has probability H. Then the table I list, each column would be the action of the high type of the other player and the action of the low type of the other player. So, for example, the second column here is the high type report himself as the high type, and low type report himself as the low type, which means it's truthful reporting. And the low high would be the high type reports low and low type reports high, which means both of them would lie. And what happens with this report is if one reports high type, then I will pay a tax minus T. So no matter what the other guy does, I need to pay a tax. So if I report as the low type, if the other guy reports as the high type, which in the first case, no matter what the other guy's type is, they will always report high type. So I'm the only one reporting low type. The government will make an investigation. If I lie, then I need to pay a fine minus F. The fine is of course greater than the tax. And similarly, if the other guy reports low, the government will randomly choose one of us to investigate. So there's only half probability of getting a fine. So the expected payoff is minus half F. So in the middle, we need to use the probability of the other guy being which type. So there will be probability 1 minus P. The other guy being the high type will report high. In that case, I need to pay a fine of minus F. And similarly, there is P probability of the other guy being the low type, which reports being a low type here, which I will pay half of F. So if you simplify this, then you can get a expression 1 minus half P multiplied by F. So similarly, what happens here is, I'll write down. So with 1 minus P probability, I will face a high type, which reports himself as the low type. Then there will be half probability of getting a fine. And similarly, there will be probability P. I meet a low type that misreports himself to be the high type, which then I will for sure get a fine. So if you simplify this again, you will get some expression like 1, no, it's half P multiplied by F, if the algebra is correct. So I'll erase the algebra. And similarly, we can complete the table for the low type. So the first table is basically, if I'm the high type, I face two opponents. One is the high type of the other guy, and one is low type of the other guy. Similarly, if I'm the low type, I still face those two. But the problem is, if I report high type, I pay the tax. If I report low type, because I'm not lying, so I don't need to pay a fine. So I get 0 in all cases. So to find the Nash equilibrium, the first thing you notice is the low type will always report low. Because 0 is always greater than minus T. So this observation will make the top table a lot easier as well. So the low type guy will basically never report H. So these two columns are not relevant. So what's left is basically we need to decide which one to choose, either H or L, depending on these two cases. So we should consider each case one by one then. So suppose the other guy chooses H, which is, we basically cover up the other column. I only look at this column. Suppose the other high type guy report truthfully, then what will happen is, given the condition in the question, so I am doing the last part of this question. So given that condition, I have minus t is should be greater than minus 1 minus p over 2. So one thing you need to be careful is the minus here. So in the question, there's no minus. When you add a minus, you need to reverse the sign. So that would be why I have this. So if this is the case, given the other guy chooses high type, given the other guy chooses to report high type, I will report high type as well. So the H and H would basically be a best response here. Given that the other guy report high type, I will report high because this number is higher. And given that I reported high, the other guy has incentive to report the high as well. So that'll be why this would be a Nash equilibrium. The way we specify Nash equilibrium is basically a base in Nash equilibrium. There are 4 components. One is player 1, high type and low type. The other 2 are player 2, high type, low type. There's a 1 here. So I need to specify 4 things. What I will do if I am the high type of player 1, so I will report H, and if I'm low type, obviously I will report L, and similarly, player 2 is symmetric. The other case is this case. So suppose the other guy reports L, then I will report L as well, because given the condition in the question again, this number is greater than the other number. So minus t basically should be smaller than minus half f. And in that case, both of us will lie, and that's the Nash equilibrium. So the second base in Nash equilibrium would be LL and LL. So no matter what type I am, I always report no, having the low income. So the last one, there is actually another one, which is a mixed strategy based in Nash equilibrium. So I need to find the weighting first. So suppose the other guy mixes with probability alpha and 1 minus alpha. I need to be indifferent between reporting high and low. So what I will be doing is I assign probability alpha to this column. So there will be probability alpha that I face something like this. And there is probability 1 minus alpha that I face something like this. Then when deciding, I actually need to calculate the expected payoff. So we have, if I report H, then I will get alpha probability of minus t plus 1 minus alpha probability of minus t, which is still minus t. The other one is a bit complicated. Alpha probability of minus 1 minus half f plus 1 minus alpha probability of minus half f. Okay, and then this is equal to, after some simplification, is half L 1 minus half 1 plus alpha minus p alpha. I think I wrote something wrong here. So there is a p here. Okay, so after you simplify, you need to choose an alpha equal to alpha star such that I'm indifferent. Me being indifferent, since the game is symmetric, the other guy will be indifferent as well. So we basically have minus t is equal to minus half f and multiply by this thing. And this is the alpha star. So if you solve this thing, you can get an alpha star that works. So again, this thing is what if I report L, if the other guy mixes that way, and if I report H, the other guy mixes with alpha and 1 minus alpha. So then we can calculate the mixing probability. The other base in Nash equilibrium would be specified like I will report H with probability alpha and L with probability 1 minus alpha. With the low type, I will always report low, so there's still an L here. And similar thing happens with the other guy. So to summarize, there are 3 Nash basic Nash equilibrium. One is truthful reporting, one is always lie, and the other one is the high type mixes.